My name is Sai Teja from ECE. Today my topic in control system is procedure for converting block diagram into signal flow graph. Let us see. The block diagrams of consist of blocks, signals, summing junctions, and there are blocks. This represents subsystems typically modeled by and labeled with a transfer function. Signals input and outputs of blocks, signal directions indicated by arrows. Could be voltage, velocity, force, and etc. The summing junction point where signals are algebraically summed or subtracted indicated by negative sign, near where there is signal joined as summing junctions. This is the signal. The summing junctions are represented as shown. Standard block diagram forms. The basic input output relation for a single block is U of S is given rise to Y of S through G of S. Y of S equal to U of S into G of S. Block diagrams blocks can be connected in three basic forms: cascade, parallel, and feedback. These are the three types block diagrams are connected in basic forms. We will next look at each of these forms and derive a single block equivalent for each. The signal flow graphs. An alternative to block diagram for graphically describing system is signal flow graph. The signal flow graph consists of nodes and branches. Nodes represent the signals, branches represent the system blocks. Branches labeled with system transfer functions. Nodes sometimes labeled with signal names. Arrows indicate the signal flow direction. Implicit summation at nodes always a positive sum. Negative signs associate with branch transfer functions. The block diagram to signal flow graph. To convert from a block diagram to signal flow graph, identify and label all signal on the block diagram as shown in figure. Place a node for each signal. Just make a node as each signal as shown in figure for every points. Connect nodes with branch in a place of blocks as shown in figure. These are the blocks. Connect, maintain correct direction. Label branches with corresponding transfer function. Negate transfer function as necessary to provide negative feedback. If desired, simplify where there is a possibility in the signal flow graph. Convert to a signal flow graph. Example 1. Label any unlabeled signals. Place a node for each signal as the first point for the rule. And we connect nodes with branch, each representing a system block. Note the -1 to provide a negative feedback of x1 of s. Connect node with branch is representing a system block as shown r of s, x1 of s, e of s, u of s, y of s, and this has h1 of s, 1, d of s, g of s, and h2 of s. Note the -1 is provided to the negative feedback of x1 of s. Nodes with single input and single output can be eliminated if desired. This makes sense for s1 of s and x2 of s. Leave u of s to indicate separation between controller and the plant. The difference are signal flow versus block diagrams. Signal flow graphs and block diagrams are alternative through equivalent tools for graphical representation of interconnected system. A generalization, not a rule. Signal flow graphs more often used when dealing with state space system models. Block diagrams more often used when dealing with transfer function system models. And these signal flow graphs and the block graphs. The signal to place, and we should never forget the rules. To convert from block diagrams to a signal flow graph, identify and label all signals on the block graph. Place a node for each signal. Connect nodes with branches in a place of the blocks. Maintain correction direction. Label branches with corresponding transfer function. Negate transfer function as necessary to provide negative feedback. And if deserved, simplify where there is a possible to simplify the signal flow graph to convert. An alternative to block diagrams for graphical description is signal flow graph. It consists of nodes represent signals, branches represent the system block, and the branches labeled with system transfer function, nodes labeled with signal names. Arrows indicate signal flow direction. Implement summation at nodes. Always a positive sum. Negative signs associated with branch transfer functions. Standard block diagram forms. The basic input output relation for a single block is y of s equal to u of s into g of s. Block diagram blocks can be connected in three basic forms: cascade, parallel, feedback. We all next look at each of these forms with branch transfer function. Label any unlabeled signals. Place a node for each signals, and the nodes are r of s, x1 of s, a of s, u of s, y of s, and x2 of s. Connect nodes with branches, each representing a system block. Note the -1 to provide negative feedback of x1 of s, and where this connected to e of s. Nodes with a single input and single output can be eliminated if deserved. This makes sense of x1 of s and x2 of x. To indicate separation between controller and plant. And the signal flow graphs and Block diagrams are alternatives. Through equivalent tools for graphical representation of interconnected system and generalization. Signal flow more often used while dealing with state space system models. Block diagrams more often used when dealing with transfer function system models. Thank you for giving this opportunity.